Hello everyone, in this video we're going to consider the introduction to combinatorics. It's a analysis and approaches topic, and I hope you will enjoy this video and the concept itself will be clear for you by the end of this lesson. And let's start with the permutations, but before this I want to remind you how to find the factorial, what factorial means, and how to use the factorial in the context of the combinatorics. So here, given the n factorial, by definition, the factorial is a multiplication the number with the next number reduced by 1, and so on up to 1. Yeah, so it's a definition of factorial. For example, if we have 3 factorials, it means that we have to 3 multiplied by 2 multiplied by 1, it is equal to 6. And the same way 4 times 3 times 2 times 1, it is 24. Okay, now let's consider the example. Let's understand this topic using the example. Let's say that we have 3 letters. So we have letter A, letter B, and letter C. And we have to form 3 simple words. So we have the word, and we have to place these letters in this word. So the question is how many different words we can construct with these 3 letters. For the first place, we can put any of these 3 letters, right? Either B, A, or C. Okay, so that's why I will write here 3. Then for the second place, we will also could put the letters, but this time it will be 2. Yeah, because 1 letter is used for the first place. Okay, so here is 2 candidates for the second place and only 1 candidate for the last place. That is why we can say that 3 times 2 times 1, it's 6, yeah? And what this 6 represents in the context of the real life? It means that there are 6 different words could be constructed from the letters A, B, C. Let's list these words and see how these words are looks like. So A, B, C, the first letter, the first word could be constructed is simply A, B, C. Then A, C, B. After that, word starts with B, B-A-C, and B-C-A, right? C-A-B and C-A-B and C-B-A. So there is nothing else, only 6 different words could be constructed. Okay, so this 6 numbers, so 6 number of the words, so 6 words here, what this permutation says. Okay. In other hand, we can say that also this is 3 factorial, right? So it means that number of permutations is 3 factorial or n factorial for the general case. Let's have a look at the formula. So the formula is written this way. The number of permutations of n different objects is n factorial equals to the definition of factorial, right? And now let's see how this concept is applied in the questions. Find the total number of different permutations of all the letters of word smart. Word smart, there are 5 different letters, right? So it means that for the first place, there are 5 candidates, then 4, then 3, then 2, then 1, right? So we are all multiplying together, and that's how we will get 5 factorial. So the total number of permutations here is 5 factorial. So the question is solved. So 5 factorial, it's 5 times 4 times 3 times 2 times 1, which is 120. Okay, let's turn to the next question. You can play back, just shift your slider to the 1-2 minutes earlier and replay. Okay, so the second question is about the books. So the books could be arranged on the shelf, 9 different books, and the question is how many different permutations, what is the total number of permutations given? So 9 different books. Okay, 9 different. Obviously, it is 9 factorial. I will leave the same. I hope you will use a calculator to find this number because this number is quite big. It's takes time to calculate without calculator. Okay, now what if we will have another option? What if we will have letters A, B, C, and let's say E? Yeah. How many three simple words we can construct from these 4 letters? For the first place, we can place one of the 4 letter, right? So 4 times 3 times 2. Okay, so 4 times 3 times 2. And what if the number of letters will be not 4 like here? It will be, let's say, 7. So 7 letters like A, B, C, D, F, G, for example. Yeah, so we have 7 letters total. So for the first place, as we did before, so 7, 6, and 5. Okay, so now it's pretty much clear. Now we have to multiply. But what if it will be not 3 letter words? It will be like 4 or 5 7 letter words, or R letter words. So the size of the word, the length of the word is R. Okay, how to deduce the formula? So let's deduce the formula together. So what we can say that this number could be obtained if we will multiply this number by 4, by 3, by 2, and 1, and then straightforward we will divide by 4, by 3, 2, and 1. Okay, so what we will get? We will get the here the first row. The numerator is 7 factorial, right? So it is 7 factorial. The denominator is 4 factorial. Okay, and now how to represent if we have n letters total and R, it's the length of the word to be constructed. So the R is the length of the word. So now we are introducing the symbols. So that's how we will get n factorial. So it is n factorial here, n size, and this size is R. Yeah. So since we divided, we will write n minus R factorial. So this is a permutation, the number of permutations of R objects. Okay. So the formulas look like that, as we deduced before, and let's see how this formula is applied. Now it's given the school six items proposed, and only 4 will be put up to the concert. And how many permutations of items are there? So we have n is equal to 6 and R is equal to 4, and using the formula of permutation we will use P. So P is 6 and 4. 6 factorial divided by 4 factorial, and divide by, it's my mistake 6 minus 4 according to the formula, right? So again, the formula is here and we're using the formula. Okay, and let's simplify now. 6 factorial divided by 2 factorial, and it's could be simplified by calculator. You can calculate using your calculator. And now we are moving to the next question. So the next question is about the word Singapore. We have the word Singapore, and the question is how many 5-letter permutations that can be formed. So since we have to count number of letters here, there are 9 letters total. So n is equal to 9, and 5 letter. So 5, R is equal to 5. So the number of permutations is simply 9 divided by 9 minus 5. So it is 9 factorial divided by 4 factorial. Done. Okay. Now you can calculate using your calculator, and we are shifting to the last question for this video. And what's given? Let's consider. So 4 boys and 5 girls form a line. In how many ways can this be done? So we have 4 girls and 5 girls, and 4 boys. Yeah, number of boys is 5. Okay, the question is how many ways this can be done. So it is they're sitting in the line, so it means that total number of sittings, it's 9. Yeah, 9 n is equal to 9. So for the first place we have 9 candidates, 8, 7, and so on. So it is 9 factorial. So the answer for this question is 9 factorial. 9 factorial. Okay, and let's turn to part A. Yeah, part A. In part A, it says that the first 2 girls to be seated. First 2 girls. So we just placing our seats. So how many? 8, yeah, and 9. And for the first place, since there are 5 girls, there are 5 candidates for the first place, and for the second place 4 candidates, right? and remaining we have 7 places, and there are 7 kids with no meaning of the gender could be arranged. So that's why we can write it 5 times 4 times 7 factorial. Okay. Okay, and B part. So part B. So the question part A is done. In B part, the first is a boy and the last is a girl. First and last. Again, we have 9 seats. 1, 2, 3. 9 seats. First is a boy and the last is a girl. So for the first place, how many boys here? So we have total 4 boys. So 4 candidates for the first place. It's booked, yeah. And the 5 candidates for the last place. It's also booked. 5. Okay. And it means that we have 7 remaining, and it doesn't say that it is somehow restricted or they're sitting according some rule there. It means that we can write as simply 7 factorial. So the total number of permutations here is total number, so total permutations, I will write this way, equals to 4 times 7 factorials times 5. Okay. Yeah, it's actually the same as you notice it, the same as in part A, but it does matter. The matter is the we answered the question correctly. And part C and D, I leave it to you. So if you will need, please ask me in the comments. I will show how it could be solved in the next video. I hope you have enjoyed this video. See you next time. Enjoy the day, and goodbye.